Hey, hello there. Welcome to another class. Let's check the sound here if everything is fine. One, two, three. Hello, good night. Welcome. Hey, hello. Okay, looks good. Well, good night, good day, good evening, where you are or when you are watching. I hope you have the best. So, today, today's class is another classical example that we learn to have a good example of like nested if comments. There is one detail here. Read three integers numbers or integers and print them in ascending order. And there is a distinction here, say non-descending. Just to make sure that we understand this, usually when you say non-descending, that means all the numbers that we got, and they are from the smallest to the highest. However, if there are duplicates, we're gonna show them. For example, if we get the number 5, 3, 1, 5, 7, 1, 9, 2, 2, 3, 3, and 2. If you're going to put those numbers in really ascending order, sometime this we feel like this. Okay, let's get those numbers and let's show them in ascending order. That will be something like this. So 5 goes here, 1 goes here. However, we remove the duplicates. So it will be something like this. They are in ascending order. When we say non-descending, we keep all the original numbers. So will be something like this: 1, 1, 2, 3, 3, 3, 5, 5, 7, and 9, if I'm not mistaken. So those are the same numbers that we got in the input. However, here is just ascending order, because in ascending order we don't have duplicates, because otherwise there's not in ascending order anymore. For example, 3 and 3, they are not in ascending order. Sometime you have to clarify. Oh, I hope we are not in trouble because I'm getting this thing here about my speed. So let's see how it goes. I'll check a little bit. If it's bad, I stop and start again. So sometime if you are in a code interview or is a requirement, you have to clarify. Because in theory, ascending order cannot be like this, because 1 and 1, they are not in ascending order. When we just say non-descending, let's see, okay, it's not descending, so that means this is correct, it's non-descending. Cool, it's just a little distinction that people like to do, but in this case, we are only dealing with three numbers. And for us, let's go, I'm afraid to waste time again, because I already have issue like this before, and what happens is the video later on is like a mess. Let me do this, I will stop. No, I will take the risk. Let's see how it goes. So what I do is I open the ScholarDraw and I reset the canvas and let you think a little bit here. Oops, let me do this. Oh, now it's gone. Looks like it's better. Look, see. I hope my son is not playing video games or watch some movies. So what happened is our program, let's represent our program here, will get as input three numbers, three integer numbers. Let me fix this arrow, something like this. So we'll get three numbers. Let's call here N1, N2, and 3. We don't know the order. Could be something like examples, like let's go here, something like, could be 1, 2, and 3. Oh, let me put below so I can go over. So something like it could be, oh, actually, no, let me do this and something like it. Could be 1, 2, and 3. Could be 1, 3, and 2. Could be 3, 2, and 1. 3, 1, and 2. And of course, could be 56, 12, and 78. For each one of those cases, we have to provide an output that are exactly the numbers provided. For example, in the case of 1, 2, 3, let's go here like case 1. Let's do this. So case 1 will return 1, 2, 3. Let's put this in the output. Will be 1, 2, 3. Let's copy all this so make it easier for us. I move this a little bit down and then this. In case 2 should be 1, 2, and 3. In case 3 should be again 1, 2, and 3. In case 4 should be again 1, 2, and 3. In case 5 should be 12, 56, and 78. So now what we need to do? Well, we have to do some logic here that will print these numbers in the correct order. So if we think what are the options for those numbers, we have to think a little bit. So could be something like this. The numbers could be read in ascending order. Or we could have something like this, N1, N3, N2. Could be N2, N1, N3. Could be N2, N3, N1. Could be N3, N1, N2. Or N3, N2, N1. If we play a little bit, you'll see it'll be like 6 possibilities. The first one being the smallest, and then we have number 1 and number 2 in the second and third. Then the second number being the smallest, and then we have the first and the third in the second and third. So the same. So actually what we need to decide is we will print something based on a condition. We know that for us print is a little bit different. We do console.writeLine. In Python will be print, or all the languages just write, depending on what they're doing. So basically we have to decide when we'll print in this order. Well, it's kind of easy, you know. When N1 is smaller than N2, we remember all the equals, no? And N2 is smaller than equals than N3. We do this. When we print in this order here, oh, let me, instead of do this, I'll just put this. When we print in this order? Well, when is exactly like this. N3 is smaller or equal than N3. Oh, N1 is smaller than N3. N3 is smaller or equal than N2. And then so on. You got the idea. Now we already have in our mind how we can break down those nested ifs. As long as you know the condition and what need to print, we already know how to write them. Cool? Sounds very simple. Now that we have an idea how to solve, we go to our idea. As we're going to read the 3 numbers, I think we already have a question that read the 3 numbers before. So I'll do the copy and paste. Like this. And bring it here. Now that we have the three numbers, we will start our verification. If n1 is more or equal than n2, and remember, we can't in C#, some other language allow us to do this, but we can just type like this. I did here because it's a human that is going to read, so we know that we are breaking down into two checks. Some language allow us to just write this exactly way without the logical operator. But in C#, we can't. There is some other ways that we can do, but not easily. So, and then if n2 is more or equal than n3, that means we will print in this order. We'll do an interpolation here. And then we'll print n1 space n2 space n3. And now, okay, if it's not this case, let's try the next one. Else, if we're gonna check n1 is smaller or equal than n3, and n3 is more or equal than n2. If that is the case, what you do, we will print exactly that order. It will be 3 here and 2 here. Still, there are more cases to check. Else, if n2 is smaller or equal than n1, and n1 is more or equal than n3, we will print in that order. That will be n2, n1, n3. Now we check the other case. Else, if n1 is the smallest one, but now if it's smallest than n3, and n3 is smaller or equals than n1. So that means this will be our order now. n2, n1, or n3, and n1. Now there are two more to go. It's 2 for each number. That is the smallest one. So else, if, now we're gonna check if n3 is the smallest one, n is smaller or equal than n1, and n1 is smaller or equal than n2. If that is the case, will be n3, n1, and n2. Else is the only option now that will be n3, n2, n1. So as you can see, we have 1, 2, 3, 4, 5, 6. All 6 possibilities we are covering with this nest ifs. Okay? So how do we read this? If we get this number, let me put a breakpoint here. In like already in ascending order, so this will be true. So we print this and we bypass all the else. And if we think about this, it's like this. Let's try to write in a little different here, so just to see if it make easier for you to see. Some people prefer to see this way. Actually, let me just do this. Oh no, I have a better idea. You get, oops. I will get all this and I will give a tab. So now I will go here. I will get all this and I will give a tab. Now I will come here. I will get all this and give a tab. Do you see that we are moving to the right? Because this shows us easily that all those else ifs, they are nested. So when I learned, we had to write this way. So this forced us to understand that, okay, we check this if this is true, we do this. If it's false, we just ignore all this else. That will be this one, right? Oh, are we missing one here? No, it's this one is closed. If this is false, if this is false, then we go here. Then we check something else. If this is true, we do this, and then we move to the next. As they are nested, we only move to the else if the expression is false. If it's true, we do what is here, and then we ignore everything else. I will revert to the other method because this is the most, I don't see anyone writing this like this way anymore. So this is how we read it. If there is a if, and do you see that they are all nested here? Else if, else if, else if. That means if one of them is true, we just ignore everything else. So if the numbers are in this order, this will be false, this will be false, this will be false, this will be true. We do this, and then we ignore everything else. So what you do to try to see this? Let's put a breakpoint and let's run it. And let's confirm we didn't do any mistake when you are writing those things here. So let's put like 10, 20, and 35. So we're gonna check 10 is smaller than 20 and 20 is smaller or equals than 35. This will be true. So we'll print that order and then we automatically jump all the else. When we jump all the else, we jump everything here. If we run again, and then we put 25, 10, and then 50. That means this first expression is false already because 25 is not smaller or equal than 10. We're gonna go to the else. Then we check again if any one is more, not again, the first time, if any1 is more than 50, 25 is more than 50, that is true. However, check if 50 is smaller than any2, 50 is smaller than 10, no, so it's not that case. We're gonna check again, any2 is smaller than any1, 10 is smaller than 25, yes. 25 is smaller than 50, yes. So that is the case that we will print, and then we ignore everything else. So we will print the right order. Did you get the idea? So yeah, so just play with it so you can, it's always nice to be debugging to understand. But I would like to show you something else that is very common, and don't get concerned about it. There is always a better way to do, a way to simplify. And it's interesting because let me call this here the method 1. Method 1, okay? Then let's learn a different one. So let's just copy this here. But before, I want to bring something else that I saw a video today that I like it. YouTube recommended and I love it. So it's something like this. Let's see if I can remember exactly the example, but something like reset the comments. This is not related with that specific problem, but I will use like the video I saw today about math. So imagine that we are trying to divide, what the number was 84 divided by 7. There is many techniques to help do division. And what the guy was explaining today is, well, what if we try to simplify this number? Because you can think, okay, 7, I know that if I multiply by 10, will be easily be 70. So then I know, okay, I gonna need 10 sevens. 84 is 7 plus 14. And then you say, oh, I need 10 sevens plus 2 sevens. So the response will be 12. So the same problem, we just break down in smaller like problem, and then we can solve them. This is a technique in coding called divide and conquer. It's from Napoleon, that he had, the historical books mention that he has a technique when they're trying to invade a place. They do some mock attacks, like they will make whoever was at land to fight each other. So, for example, they get costume or like the flag and thing from one tribe or one group, and then they attack another one, and then they just left there some tips show, oh, you got attacked by the other, and then they start the internal war, and then later on they come, they are like weakened they are fighting each other, so it'll be easier for them to conquer. So that is the idea about divide to conquer. That is what we did. We break down 84 in two parts, and then we have easier part to solve it. Cool? Okay. So now let's go. How can we make something similar? Oh, sorry, I have to get this one. For the problem we have now. So we had three numbers. Oh, let me go here. Number 1, number 2, and number 3. So what is our problem here? We want to make sure that those numbers are always in the correct order, ascending order, or non-descending, as we're gonna, if they are duplicate, like 3, 3, and 3, we're gonna print 3, 3, and 3. So imagine that we have the numbers here, something like 5, 2, and 8. So what we could think is, what if we make those first two to be always in the right order? For example, if number 1 is greater than number 2, let's swap them. Do you remember that we had an exercise to swap the numbers? So we may have a logic to make sure that the number 1 is always smaller than number 2. If they're not, we change this, we swap them, 2 and 5. Now, if we know that the number 1 is always smaller than number 2, now it's just a matter to figure out, instead of 6 options, if number 2 goes here before, oh, number 3 goes before, go in between, or is the last one. So it's the same problem, we just break it down in 2 different steps. We thought, well, if we make sure that the first 2 are always in order, now we just need to figure out 3 options, because N1 and N2 will be always in this order. But now we can ask if any 3 is smaller than N1, will be N3, N1, and N2. If not, we're gonna check any 3 is smaller than N2, yes. So then it will be N1, N3, N2. Otherwise, it will be N1, N2, N3. Oh, otherwise, yeah, otherwise it will be N1, N1. So if we are sure that those 2 are in order, it's easier to figure out. As we cannot force our user to provide them in order, we can do a trick. We change them. We play the user by changing those numbers, and then we can give the right response. So now, what is going to happen here? We'll make the solution simpler, because we're going to do this. If number 1 is greater than number 2, they are not in order. What do you do? Well, let's use a auxiliary variable to save N1. N1 will receive N2, and then N2 will receive also. We already saw this logic before. When we want to change two variables, we have to use a third one to save one of them. That one that is saved, we can assign the other one, and now the other one and now is the catch. After we do this, it's not a nested if anymore. It's just a matter to check, okay, if any tree is smaller or equal, whatever, than n1, that means the order will be n1 or any here, n3, n1, n2. Because now we only have three options. N1 and N2 will be always in that order. Now we need to figure out where to put N3. Then I will say else if N3 is smaller or equal than N2, the order will be N1, N3, N2. Else, if it's not any of those, will be the natural order. It will be N1, N2, N3. So this is just to show you that logic is very interesting. And if we think a little bit more, we may find an easier solution. Is that why coding is never a sprint? It's always like a marathon. It's not about to be so fast. Of course, you cannot spend like 3 months trying to figure out what's the best way to do this. But it's not a good idea to just jump in the first idea you have without maybe try to figure out other better ways. Right now, you are learning, so don't feel bad if you didn't think about this. Probably no anyone that is just learning would not. It's like everything else that we're learning. In the beginning, we need to have some ideas so our mind can just start to prepare. And then later on, we're gonna have our like gotcha moment. Pay attention that this if is after this one. So we make sure that those two are ordered. If this is greater than N2, we change them. If they are already in order, if N2 is not greater than if N1 is not greater than 2, we just don't do this. Remember, the if there is no else, this is executed only if this is true. If it's false, we ignore it. It's like this is not there. If we have a if a else, then it's different. It's like we go or here or we go here. If this is false, then we go here or here. So now what I do is just to test, I remove the breakpoint so we make it faster. Let's type and let's see how it goes. Oh, actually no, let me put a breakpoint here so we can see what is going on. So let's put 10, 25, and then 50. Why this guy is not showing the border there? Let's see. So what you're gonna test? 10 is smaller than 25. Yes, so we do nothing. They are already in the order that we want. Now we're gonna check any 3 that is 50 is smaller than 10. No. 50 is smaller than 25. No. So then we're gonna print N1, N2, N3. Let's run again. And now let's try that case. Let's put like 50, 10, and 80. 50 is greater than 10, yes. So let's change that. Now look, N1 was 50, N2 was 10. Now N1 is 10, N2 is 50. And then when I ask, N3 is smaller than 8, is smaller than N1 now is 10. Pay attention. It's not. Any trace is more than 80, it is more than 50, no. And then we print this order. Cool. So now play with it. The idea of today is to explain how to write ifs, nested ifs, and to plant a seed that logic is interesting. And if we spend a little bit more of time, and of course with experience, we can find solutions that are cleaner. It's easier to understand. Of course, maybe there are some people that say, no, for me, this is simple. I just have 6 options. This one, you have to do this and that. So I get some people not like it, but I'm showing because sometime it's going to help you. Later on, we'll see that solution that is way better than the previous one. And there is no discussion. It's not up to discussion. Yeah, this is good, this is bad. But now it's kind of, okay. This we have like 43 to 58, about like 15 lines. And then we have from 38 to 20. So 18 lines. And then someone say, oh, I can save space here. Yes, true. But I hope I help you to kind of like get this idea. And that's it. So thank you for watching. God bless you. See you next class. So 18 lines. And then someone say, oh, I can save space here. Yes, true. But I hope